Okay, so today's video is actually something I've been asked about a ton, and it is the ACT pre-calculus questions. And these are pulled mostly from the released April test that was in 2026 and the October test that was in 2025, and some from the ACT Red Book. But this is a very practical excerpt video from our ACT Death Math course that is showing these real ACT problems and how to practically solve them with pretty much without losing your mind. So if you are using this to study, please pause the video before I explain the questions so that you can practice answering them before I am talking through the answers. But regardless, make sure you go ahead and hit subscribe so that you don't miss any more videos. And if you really want the course, it is linked down below. But enjoy. We're going to get started with something I get asked a lot, which is how do we do like the trig / pre-calc questions? And so technically there is some concepts that overlap, like if you take a separate trig class or if you take pre-calc that sneak up, but a lot of these concepts are actually overlapped in geometry and algebra 2, but every school teaches it a little bit differently, so it's kind of hard to group it. But that being said, they are seeming to repeat a lot of the same, like I would say like triggy concepts, the best way to describe it. And it's a loose grouping. So I'm going to talk about each one of these. Some of these I do use calculator programs for, which is linked in this course if you don't already have it, but I want to show you kind of the main way that most people do it, just in case you don't have or want the calculator programs. Okay. So 19 is our first one. This is a very common one, and they normally have one of these per test where they're asking for the period and or amplitude. So we're going to talk about that. So the function y equals 2 sine 6 pi x is graphed in the standard xy coordinate plane for x radians at the interval blank. What is the period and amplitude of the function? So I chose this one because it layers some of the options that I've seen. Some tests I've seen it where they're just asking the amplitude, and that's like a total freebie as long as you have this equation up here. And the key thing is, and this is where it doesn't matter if you've taken like a trig class or pre-calc or whatever, is all you have to do is look at that dang front number. It doesn't matter if it's sine or if it's cosine. That is going to be your amplitude every single time. And so there's a freebie right there. So knowing that, what we can do is we can go ahead and cross out B and we can cross out D because both of those amplitudes say 4. Now we are down to 2 options here. Most students do eyeball this. There is a little bit more like kind of complicated way. Well, it's semi-complicated, but on this one, it actually really wants you to just kind of eyeball it. So since this is a 1 and all of these are fitting between like the 0 and the 1 without going too like deep in the weeds, the period's going to be 1/3. They are going to mass group these, or at least they have in the past, where they're not going to be like, hey, is it like 1/4 and 1/3? They're normally not going to do that. And it's kind of one of those that they're going to give major hints. So this is one you hopefully will be able to figure it out. I kind of think these are freebies once you kind of get the hang of it. Okay, so this one was on the April 2026 ACT. This is one people were talking to me about, and they were like really stressed about. I liked this one because they give you actually a lot of the information. You may not be familiar with the formula, and that's okay because they typically don't expect you to memorize this formula. So on number 31, for DEF shown, which of the following equations, when solved for x, gives the length of DE in inches? So they actually give you the formula that you pretty much need to plug in, and you kind of have to notice their pattern where it's like sine D and then little d. And the only thing that's tricky is you just have to think like the opposite. So for example, this is grouped together. So that would be a little d right there. And then you're pretty much looking from the opposite. So you probably get the hang of it by now, but like f, that's going to be little f, but that's kind of the gist of it. So we are looking for where they have the question mark there. They're not so nice that they like call it f on the answers. That wouldn't be very nice, but we're going to call it x like they do. So write that there. So what we have to notice is that these two are friends. So they're going to be grouped together. And if we were following the pattern, it would look like sine f over x, which in other words would be sine 73 over x, because that's the mystery. So that actually eliminates g, and it also eliminates, as I'm like looking through this too, because we need to have this in here. It eliminates j. So now we need pretty much a matching pair. And one thing that you need to remember, and hopefully know this, is all the degrees in a triangle add up to 180, which is relevant because we don't have d over here. So in our calculator, we just go 180 minus 45 minus 73. Now, some of y'all are probably head mathers and can solve this on your own. I like to double check things. So that angle right there is going to be 62. It's not 63. And with that there, now we've got a little bit of a matching friend. So now that we know we've got a sine 62, I keep writing 3. And then that one matches with the 13. And the only one that now works is going to be h. Most people just don't understand or like don't know that it's like the opposites that actually matter, but that's kind of like your key way to look through these. Okay, let's keep going on. So this one upset some kids, especially if they've not seen this before, but like, we're going to simplify it a little bit. Okay, so on 34, the circle is shown in the xy coordinate plane, is centered at the origin and passes through 1, 0. Suppose the circle passes through point P in quadrant 1, such that the measure of NOP is pi over 3 radians. This is a lot, and I totally understand that. So let's try to eliminate and kind of boil down like what this is actually looking for before we kind of get in a panic because of unit circle. And if you don't know what the unit circle is, hang with me. We are not doing a unit circle crash course. So we have this point right here, and then it's asking such that the measure NOP is going to be pi over 3 radians. So let's think about it this way. So what they're saying here is that it's in quadrant 1. We're going to kind of guess for a second. And we have a few kind of different ways to think about it. So first and foremost, we are looking for the y coordinate. So here is what you do if you're like totally stuck. So the way this works, if like a 1 is over here, this is a 1. I mean, it should be -1. This is going to be a 1, and then this is going to be a -1. So you really have to put on a red flag for a couple of these. We talked about, especially in the geometry, eliminating the bad options. This is like a perfect kind of situation to do this. So if we just think about, and I'm going to use this, I started grabbing my handheld calculator. If we just kind of think about C and D first before we kind of get too deep into this, is let's go math and then frac. Actually, let's clear that. So let's find out what the number is for that square root of 3 divided by 2. I like decimals so much better than fractions, and maybe you're feeling this same way too. So we go enter, and as you can see, I'm actually glad I did that. I typed it in wrong, and this highlights how not to type it in. And what I mean by that, and I'm filming this kind of later, so maybe my brain's just tired. But that being said, this is a good way to show like this does not work well. You really have to think about putting this into parentheses. And then actually, I lied. Normally it doesn't work well. Yep, it's just I'm tired. So bear with me on this one. So this one right here is going to be a 0.8, like 86. And you've got to decide, like, does that sound potentially like an option? Maybe. It's kind of looking like if this is going to be up here, then likely the Y is going to be a little bit higher. Same thing with C. And then we are looking, like I said, for the red flags. And then that one's probably an option too. At first, when I saw those, and like I said, maybe just my tired brain, when I first saw those, I was like, oh, that's going to be bigger. And then once you kind of visualize it in decimals, then you're like, okay, that's where it's at. And then we know what 1/3 is. It's like 0.333. So it's going to be smaller. And yeah, so let's kind of chat about a couple of things. For one, I do have a degrees to radians option, and that's normally pretty helpful, to be totally honest. The other way you kind of can like hack through this bad boy is kind of converting it by hand, which it's not in geometry. So we've just got to convert this one to actually 2 degrees. And so if you've got pi thirds radians times, let's go ahead and convert it in the way that we can convert it by hand. Let me move this out of the way. It's going to be pi over here and then 180 up top, because that's going to cancel out our pi's and create degrees. And then you probably can do this in your head, but that's going to be 60 degrees. Okay, so restarting number 34 in 3, 2, 1. So on number 34, man, I don't like the unit circle. This one's unit circle-y, and we can't really find a hacky way around it. I'm looking into making a program on it. TBD, I've been going back and forth with Claude. So kind of the quick high level. So all of the circle is pretty much 2 pi radians, which also equals 360 degrees. You've got a coordinate here, and this is just kind of the big flag. Like, this is the unit circle at this point. So the kind of quick hack with the unit circle is like your x's are going to be cosine pi thirds. And then your y's are going to be the sine pi thirds. And this is just kind of telling you like what you would plug in based on what it is asking for. So since this one is really asking for the y coordinate, this one you're going to want sine pi over 3. And then you're kind of asking yourself like, so what's the option then at that point? So you kind of need to figure it out. One way you can do it is with your calculator here. And I've heard rumors on the Evo that it's like candy unit circle. I haven't played around with that yet. I have it. I don't know. So as we are going here, here's the key thing. We've got to go into mode and we have to make sure we're in radians, which is correct. So we're good there. So let's go second quit. And then let's go ahead and go sine. And then we go second pi divided by 3. We hit enter and you're like, I don't see that number there. So let's match some decimals. So you probably can eyeball this, not A or B. But if you go square root of 3 divided by 2 and hit enter, they match. And so your answer on this one is going to be D. If you didn't like that, me neither. I feel the same way. Like I did not love calculus. I did pretty like well in it. I didn't like it. Okay, 37 is from the Red Book. This one's much nicer, and I've seen some similar ones to this. So on 37, whenever they give like this much stuff, I'm like always going to what the question is asking. So which of the following values is closest to the length of BP? So that's kind of our goal. I just like to know a little bit what I'm looking for. So it's talking about the radius. The length of AP is 12 centimeters, and the measure of APO is 20 degrees. So which of the following is going to be BP? And they are pretty much giving you like some massive hints here. Yeah, they want you to use SOHCAHTOA. I'm sorry to break it to you. So you have kind of a couple ways to go about this. As I'm looking through this, a circle is perpendicular. So let's kind of think about it this way. And I'm going to think about it slightly different. So you have two options here, but what you can think of is if we like focus on this 20 degrees and if we can at least find like PO, then we can get really close. And then I can show you another way to do it too. So this one right here is good old SOHCAHTOA. Like I said in the geometry video, please know SOHCAHTOA. It's like a ride or die situation on the ACT and actually the SAT too. On this one here, so what we're looking at is if we are going for O and P, we know that this is obviously 90 degrees and we are working with kind of a couple of things. So the way I would think about it is if we are looking for that side, we've got to figure out what angle we're going to do. And the materials that we kind of have is we've got cosine because we have an adjacent. So we go cosine 20 degrees equals, it would be adjacent like 12 over x, which we'll just call that x. X cosine 20 degrees equals 12. They give us those rounded numbers and we can use that too. So if we are going to solve for that, we obviously need to divide by cosine of 20, but we're not done yet. So we will use their ballpark number. So if we just go 12 and then we'll go divided by that cosine there, and that would be what, 0.940. So on this one here, we're getting like, and it's so trippy because like it's not much different than 12, which like kind of threw me off when the first time I saw it. So what is it, like 12.76? And you can kind of guesstimate if you needed to at this point what B and P is. But here is kind of, I guess that you could say the more accurate way is if we find AO, let's go ahead and change some colors. We'll call that Y there. And so if we want to find AO, we've kind of got to do something similar. So we have multiple points here, but if we focus on that 20 degrees, Y would technically be the opposite. And then we have the adjacent. So let's talk about tangent. So if we go tangent, 20 degrees equals the opposite Y over adjacent. And then what that would turn into, if you like solve down for this one, would be 12 tangent 20 equals Y. And so that number turns out to be, so we just go use their numbers there, which is like 0.364 times 12. And so that's going to be 4.368. And that's pretty much a radius there. And from this whole thing, to find BP, we need to subtract a radius. So you can kind of guesstimate it at this point, but you can go 7, 6, 5, and I'm not going to type in every number, 4.368. And that one, the most accurate answer is going to be D. A little bit tricky, but if you know like SOHCAHTOA, like you'd be fine. Okay, so I was actually explaining this one to a kid this morning, and this is one that like looks god awful, but it's actually really easy, and they like these law of cosine ones. And with this one here, so I know it's law of cosine because, well, they have like cosine in every single question, to be honest, except B. But as we're looking through it here, what we really need to think about is we don't need to deeply understand what they're doing or even really solve for it. We just need to set it up right. And so it says, which of the following expressions is equal to the distance in feet between entrance and the bench? And so this right here is what we're solving for. And we're going to call that X for a second. And what you need to know with the law of cosines, like the law of sines, there's a lot of opposites. So like these two are friends, and then that 700 is going to be friends. And it's just pretty much like an opposite situation here. You can kind of finagle it out about what like that degrees would be, but it doesn't really matter, to be honest. And I don't mean that in a grumpy way, just to be totally frank there. But our whole goal is we want to find X. And the key that you are looking for is it's always set up like this in these crazy, insane square roots. So we just eliminate those. And then the other key feature is whatever you are solving for, your goal, the angle opposite is the most important. So you can quickly eliminate that it's not 25 degrees. The angle opposite of it is a big boy. So the only logical answer is D. And this is how I see most of the law of cosine questions. They just give massive hints. They don't need you to deeply understand the concept, which is nice because I don't like it very much. The problems I like whine the most about, minus a whole other topic. But that being said, so this is going to be our last one for this video. So on 39, there's a lot going on. So a 50-foot long rectangular swimming pool with vertical sides is 3 feet deep at the shallow end, 10 feet deep at the deep end. The bottom of the pool slopes downward at a constant angle from horizontal along the length of the pool. Which of the following expressions is going to give you that constant angle? And on the situation, I don't want you to stress about like the -1 that's floating with tangent. Like just don't worry about that right now. So we're going to draw this out, and I'm going to warn you, if you haven't realized already, I am a terrible artist, but we're going to make it work. So let's use a different color. That green is pretty, it just doesn't show up really well. Okay, so we have our pool here, and so it is 50 feet long. So we'll put 50 here. In a lot of these, you just have to visualize it. So be used to drawing it. And then the vertical sides is 3 feet deep at the shallow end. And then it's 10 feet deep at the deep end. So like that's 10. And then it's a constant slope down. Not perfect, but we get the picture. That's a 3. So that being said, which is the way to solve for pretty much that angle like right here? And so we know we're using tangent. And this right here is actually going to be a 7. And the reason is like the whole deep end is 10. But we know, like, if you get in the pool, unless you have like a fancy like 0 entry pool, which those are the bomb. I really like those. But that being said, we don't have that situation. Most people don't. So on this one here, we were really focusing on like what is going to find this angle. And if we remember our rules of tangent, it is going to be the opposite over adjacent. And on this one here, it is simply going to be 7 over 50. So the answer on this one is really only going to be A. The cool thing is if like you were feeling like real skeptical about this, you can type it in, just like validate, but you've got to make sure you put it in the right mode. So if you guys want to kind of visualize it, is on this question here, if we were going to go like second, tangent 7 divided by 50, that shows pretty much the slope. And I mean, it's a big pool. Like, it goes along for a long, long time. And so that kind of logically makes sense. But let's plug in a couple of these others so for funsies. And if we go 13 divided by 50, and then that's going to be 14 degrees. And then the other ones, let's see. Now I'm just kind of curious. And that's going to be 34 degrees. And then D is going to be our weird one. This could be 75 degrees. Like that's an intense slope. So if you're really in a pickle, you can like eliminate these. But if you're like, that's a super tiny angle. And yes, it is, but you've got to think about it this way. Like, that is a huge pool. It is 50 feet long. So anyway, that's my rant for the night. Yeah, so overall, I hope you found this video helpful. Just like the other videos, I am placing the printables so that like you can ride along. And then also the last recording of the series is from a live class, and I don't think I overlap too many questions. There should be some new ones on there, but you can kind of skip through and see which one is going to help you. But that being said, I hope you do well in your ACT. I will be doing some updates to this course, especially after taking the June test, if I see anything else crazy. And don't forget to check out the calculator programs. I am adding more and more for like the 84 and the Evo. And I'm sitting here contemplating about, I might do unit circle one. I'll provide an update in the comments. So regardless, I hope you have a nice evening or morning, or regardless, wherever you're watching this.